Welcome everybody to our Math 1050 CBE 1 review. Just so you know, this is being recorded, so we are not going to say any of your names. But your faces will not be in the recording or anything, so don't worry about that, okay? My name's India Evans. I'm a recitation leader for this Math 1050 and for Josh Cruz.
I'm Hunter Slade. I'm also a recitation leader for Josh Cruz.
And I'm Ryan Austin. I am a recitation leader for Drew Rogers for Math 1050.
Okay, yeah. So let's just get right into it, Ryan.
Let's just hop right into it. All right. So for this first CBE, we're going to be covering lessons 1 through 6. That's going to be including intro to complex numbers, solving equations, intro to functions, function notation, graphs of functions, and graphs of common functions. So to start off, we are going to be covering complex numbers and all the things that pertain to that. With our complex numbers, to start off, what are complex numbers? They are really when the world starts to break when it comes to mathematics. So the imaginary number I is equal to the square root of -1. And if we were to square I, we would get just -1. And every complex number can be represented in the form of a plus bi, where a and b are real numbers and I is the imaginary part. With adding and subtracting complex numbers, we just need to match the terms when they go together. Because, yeah, I'm just going to stop right there. And you need to make sure that when you match the terms, you keep the real terms together and the imaginary terms together. You can't really mix them. They're in their own separate worlds when it comes to those sorts of things. Here, I'll go back. So for example, if we have two complex numbers in the form of 2 plus 3i and 9 minus 2i, and if we were to combine these two numbers together, like so, we would combine the 2 and the 9 together, giving us 11, and we'd combine the 3 and the -2 together, just giving us plus I. And that would be our new complex number. So it's as simple as that. Just make sure that when you're combining them, that you combine the like terms. Next is multiplying and dividing complex numbers. When multiplying complex numbers, you distribute them just like with any sort of multiplication across parentheses. And whenever you get terms like the I squared, you can simplify them because I squared is equal to -1, and so on and so forth. And just like before, you add and subtract like terms to make the form of a plus bi. So for example, if we had, let's use the same ones that we used last time, 2 plus 3i, and 9 minus, I guess I'll change it up a little bit because I don't remember what they were. We'll do 2 plus 3i and 9 minus 5i. Just like before, we're going to be multiplying across with 2 times I, and then later with the 2 times 5i, and then we'll have 3i times 9 and 3i times -5i. So for the 2 times 9, we'll get 18. 2 times -5i, we'll get -10i. With the 3i times 9, we'll get 27i. And the 3i times -5i is going to be -15i squared. From this point, we can then simplify individual terms, such as the I squared right here. That will just become a -1. And so that will simplify to being just a +15. And then we can combine like terms for the rest of our complex number, leaving us with 33 plus 17i. Just like that. When it comes to dividing complex numbers, it gets a little bit more nuanced and difficult. When you're dividing by complex numbers, you need to multiply the denominator by the conjugate of the complex number. That way it will, just like up here with the I squared, it will get rid of those imaginary numbers. And then you multiply the numerator by the same thing, and you distribute and you simplify, just like with multiplying. So let me quickly erase all this. So for example, let's do 3 minus 2i over 5 plus 3i. To divide these complex numbers, we're going to need to multiply the numerator and the denominator by the conjugate of our denominator. So our conjugate for this is going to be 5 minus 3i. And so we need to multiply both the numerator and the denominator by 5 minus 3i. When we do this, we'll distribute and FOIL just like what we did before with multiplying. And when we do, our denominator will be 25 minus 9i squared. And the I squared will just simplify to being plus 9. That is not an eraser. And I'm just gonna get rid of all of it. And that'll just simplify to 34. Cool. And then we can FOIL across on the top, giving us 15. 3 times negative 3i is negative 9i. It's negative 10i. And then the 2 times 3 is going to be positive 6i squared, which will just be a negative 6. And so if we simplify it, we will get 9 minus 19i. Perfect. And really from this point, we can just separate the 9 and the negative 19i, and that'll give us our complex number. So this is correct right here. Whoa, did not want to go to the next page. That is correct right there. But a good way to simplify it would be to just split up the real and the non-real parts to look like this.
And I believe on the test, you have to break it apart.
So you'll have to break it apart like that to split it up. So just keep that in mind. All right. So let's take a crack at it with this problem right here. So we're going to want to start off by multiplying the division on the right by the denominator's conjugate. So that will be 2 minus 3i on both the numerator and the denominator. That will get us to be the negative I out front plus 4 minus 9i squared, which will simplify to be a positive 9. That'll just give us a 13 in the denominator. For the numerator, that'll give us a, right up here, 10 minus 15i plus 6i minus 9i squared. Same thing, we've got this 9i squared will turn into just a positive 9. And then the negative 15i and the 6i will combine to just be a negative 9i, right? Yes. So we will just be left with 19 minus 9i like that. And we do have this negative I out front, so we do need to bring that in. And the easiest way to do that would be to, in this case, multiply by 1, which we can define 1 as just being 13 over 13, so that it has the same denominator as our piece on the right. With that, we've got negative 13i over 13 plus 19 minus 9i over 13. If we combine these, we will get 19 over 13 minus 22i over 13. And this is our solution just right there.
Does anyone have any questions about complex numbers?
Yes.
Okay. How did you get the 22 at the end?
So the 22, all I did was I just added like terms with this -9i right here and
Oh.
then -13i right there.
Okay.
That's all I did.
Thank you.
Yeah, of course. Are we all good on complex numbers? Sweet. And we move on to solving an equation.
Okay, awesome. Yeah, we're gonna solve equations now. So, you have already worked with these. Obviously, this is just gonna be review. We're gonna be adding and subtracting and multiplying, dividing, doing all that fun stuff and solving for x. And x may include the complex number, which is why I went over to complex numbers first. Okay. Whoa. Oh, never mind. Okay. True or false? The imaginary number negative square root of 4i is a solution to the equation x to the fourth minus 16 equal to 0. Okay, there's two different ways to approach this equation. One of the ways is to just straight up plug negative square root of 4i into the equation and see if it gives you 0 when you subtract 16 from it. Okay, so I'm going to do that way first. So negative square root of 4i, not squared. Wait, how do you erase? Oh, okay, I got it. 4i to the fourth minus 16. Okay, and we want this equation to equal 0. Okay, so let's check. How I like to do this is I like to separate the 4 out into 2 squares. So you have 2 squares, okay? Okay, and then we applied the square to each of the individual elements in the parentheses. So we have a -1, which is our negative. We have the square root of 4, and we have our I, okay? So our -1, when you square -1, you're just going to get a +1. So it's just going to go away. When you square a square root, you're just going to get the number in the square root, so 4. And when you square an I, you get a -1. So then the -1 comes back, okay? And that's still going to be squared, okay? Okay. Then you still have the -16. And then when we square the -4, we get 16. So we have 16 minus 16 is equal to 0, which is true. So we have just proved this way, this direction, that negative the square root of 4i is a solution. Okay. Okay. Another way we can look at this, just to go over, is we can just solve for the roots in the equation and then look to see if negative square root of 4i is one of them. So we can move the 16 over. We get x to the fourth is equal to 16. And then we can take the square root of both sides. So then we have x squared is equal to positive and -4. And then we can square root both sides again and get x is equal to positive -2 for +4. And then, yeah, because the square root of 4 is 2. Positive and -2. And then if we have a -4 in the square root, that's going to be a positive -2i, which is exactly -2i is equal to negative square root of 4i. Okay. Any questions on this? Yes.
Oh, okay, well, mine's like kind of long, but because like if you would be able to repeat like the little rules from that one section.
From this top?
Yeah, that part.
Yeah. So like how I separated out the square roots?
Yeah.
Yes, okay. Yeah, so when you have an exponent, if you multiply something raised to an exponent by another, the same thing raised to another exponent, this is going to add the exponents together, okay? So if we want to multiply the exponents together, we have to apply the exponent to the entire term, okay? So x to the fourth to the second, to the 2, or yeah. Now we can multiply them together. X to the 4th times 2 is equal to x to the 8th. Okay, so what I did up here, with the negative square root of 4i to the 4th, I looked at it, I was like, hey, 4 is 2 times 2. And so we can write it in this form down here. So we have square root of negative 4i squared and then squared. Okay, does that make sense?
Yeah.
Yeah. It's just useful for separating it so you're not doing the square root of, the root of 4,
Okay.
fourth root. Yeah.
Mhm.
Okay, any other questions? Yes.
So with that, did you just take like -1 and then the square root of 4 and then I squared separately and square them?
Yes, if you have something squared, if you have multiple things in parentheses that are being squared or being raised to another exponent, that square applies to both of them individually. So this is equal to x squared y squared.
Okay.
Okay,
Thank you.
It just doesn't work that way if they're added, but if they're multiplied together.
yeah, yep. Any other questions? Okay, so this is true. Okay. Yeah. Okay. Okay, now we can determine all the complex solutions to the equation x plus 1 multiplied by x plus 2 is equal to 1. Okay, so something that's really tempting for people is to do where we're just like, oh, x is equal to -1 or x is equal to -2. This does not work if 0 is not on the other side. We need the 0 there, okay? That's because there's a property in the real numbers that tells us that if we have AB is equal to 0, then either A or B is equal to 0. That's when we can bring this in, okay? So you want to be super careful with that. Okay, so what we want to do first is we want to distribute out our x plus 1 multiplied by x plus 2, because that's not going to tell us anything right now when it's equal to 1. So we're going to distribute that out. So we have x times x, x squared. Then we have x times 2 plus 2x. Then we have x times 1 plus x. And then we have 1 times 2 plus 2. So then we have x squared, combining like terms, x squared plus 3x plus 2. Okay? Okay, and this is going to be equal to 1. Okay, now we want to set it equal to 0, so we're just going to bring that 1 over. So we have x squared plus 3x, 2 minus 1. We subtract 1 from both sides. So then we have plus 2 minus 1 is equal to 1, is equal to 0. Okay, now we can do our thing where we separate it out into roots. Okay, there is not an easy pair of numbers where they multiply to 1 and add up to 3. So that's where we want to bring in the quadratic formula. Okay, so remember this exponent, this x squared has a coefficient of 1. So that 1 is going to be our a. This has a coefficient of 3, so that's going to be our b. And this has a coefficient of 1, so that's going to be our c. Okay. So we have x is equal to negative b, so 3, plus or minus 3 squared minus 4 times 1 all over 2 times 1. Okay?
Yeah, thanks, dude.
So we can simplify that. So we have negative 3 plus or minus 9 minus 4 all over 2. So that's going to be negative 3 plus or minus 5 over 2. Okay, so those are our roots. So our roots are going to be x is equal to negative 3 over 2. Remember, you want to take apart the fractions. Negative 3 over 2 plus the square root of 5 over 2 and -3/2 minus the square root of 5/2. Okay. Any questions on this? Yes.
One problem I have a hard time with sometimes is when I plug a number into the quadratic formula,
Mhm.
but something is wrong, and so it spits out an answer that looks weird.
Hmm.
And sometimes it's right and sometimes it's not.
Okay.
So is there a way to like tell if your answer is correct or not?
You can plug this back in. So like we can plug this back in to our equation that we have up here for x, and it should give us 0. If it's wrong, it will give us something other than 0. Okay, so it's a little bit more difficult on equations like this where you have fractions and square roots, but you should still get back out 0. Yeah, so that's just a way to check. Okay. Yeah, you can't see that, but that is -3 plus or minus square root of 5/2. Okay. Okay. Okay, yeah, this is the 0 factor property that I was telling you about. I was saying that when 2 or more, but I just showed you 2, if 2 or more numbers is equal to 0, then at least one of these numbers must be equal to 0, okay? And that's true for however many numbers you have. One of these 5 has to equal 0. One of these 20 has to equal 0, if it equals 0, okay? Yeah, so this is the whole reason why we can solve an equation if we set one side equal to 0. Because we know one of those has to be 0 at least. Okay. And both of them, or all of them, can be 0, but at least one. Okay. Yeah. Any questions on the 0 factor property? 0 factor property? Okay. Okay. Okay, so this is where it gets a little bit more complicated because now we want, now we have a bunch of fractions that we need to add together, and we can only do that when we have a common denominator, okay? So, easiest way to do this is multiply by the least common multiple of the denominator. So that means if you have like this x minus 5, you do not have to multiply it by that whole thing. Because if we look at it, x squared minus 5x can factor out to x times x minus 5, which we already have. So in order to make it a common denominator, we only need to multiply by this singular x. Okay? Okay. So let's do that. And then the 2 doesn't have a denominator, so we have to multiply it by the entire denominator. Okay. How do I... Okay, literally, how do I use the freaking eraser? Sorry.
Just click like one of these squares down there,
Oh,
and then erase
okay. Ah! What is happening? Okay. 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 Now, okay. So we're gonna multiply this by x over x, which is just 1, x divided by x is 1, so we're cheating here by to get at a common denominator. This doesn't need any multiplication, we just multiply it by 1. And then this one, we multiply it by the entire denominator because it needs a denominator. Okay. So we're going to get 3x squared over x squared minus 5x. Minus 39 over x squared minus 5x, okay? And then is equal to 2x squared minus 10x over x squared minus 5x. Okay? Okay. So now we're gonna bring this term over. So we're gonna have 3x squared over x squared minus 5x minus 39 over x squared minus 5x minus 2x squared minus 10x over x squared minus 5x. Okay. Okay. So now let's put them all over the same denominator. So we have 3x squared minus 39. This negative applies to each of the terms in the numerator. So this is gonna be minus 2x squared minus negative 10x, so that's gonna be plus 10x. And then that's gonna be equal to x squared plus 10x minus 39 all over the denominator. Okay. Okay. So, yeah. And then if this is equal to 0, we only need to worry about what the numerator is when it equals 0, because the denominator should not be 0. So we're just gonna worry about the numerator. So we're just gonna say, okay, we want this is equal to 0. Okay. I can see two numbers that multiply to give us negative 39 and add to give us positive 10. Can you guys see them? Okay, so factors of 39 are 13 and 3. So if we have a positive 13 multiplied by negative 3, that gives us negative 39, and then 13 plus negative 3 gives us a 10. Okay, so this factors into x minus 13, no, minus plus 13, x minus 3. Okay. Okay, and so then we have x plus 13 is equal to 0. So x equals negative 13. And then we have x minus 3 is equal to 0. So x is equal to 3. These are going to be our roots. Okay. Any questions on this? Yes.
This is, so would it also work if you multiplied to get rid of the fractions? So like, if, oh, what am I trying to think here? If you multiplied everything by x, or no, wait, what am I thinking of? By x times x minus 5, and just put it into the numerators, would it just eliminate the fractions?
Yeah. That would work if you multiplied the entire thing by x squared minus 5x. It would still just be a little more difficult, because if you look, we have x squared minus 5x, 3x over x minus 5 minus 39 over x squared minus 5x. This is gonna be we're gonna have to FOIL, and so it's just a little bit more difficult. But yes, if you multiply that equation by the same thing on both sides, it will still work. Okay. Any other questions? Okay. And then we see down here, x is equal to 3 and x is equal to negative 13. Okay. Okay, so now we want to determine all the real number solutions to the equation. So we'll just use the zero factor property because it's already separated out into terms. And we know from the zero factor property that at least one of these terms has to be 0. So we'll just check that. So if 4x plus 8 is equal to 0, then we can square both sides. 4x plus 8, 0 squared is just 0. So we have 4x is equal to negative 8, and x is equal to negative 2. Okay. So that's what x has to be for the first term equals 0. For the second term, we have 3x squared plus 2x minus 2. And we have it's equal to negative 6. I think we have an easy one there. I think we have to use the quadratic. Okay. So we have the quadratic negative 2 plus or minus 4 minus 4 times negative 2 -4 times -2 is 8 times 3 is 24. All over 2 times 3 is 6. Okay. Then we have -2 plus or minus 28. Square root of 28 over 6. So you have -2. This is this is equivalent to the square root of 4 times 7. So we can pull out a 4. So we put a 2 out front times the square root of 7. And then divide by 6. Okay. And then finally we have x squared plus 18x plus 45 is equal to 0. Okay, let's see. Okay, I'm gonna use the quadratic equation again. We have -18 plus or minus square root of 18 squared minus 4 of 1 times 45 over 2 times 1 is 2. So I need to pull out my calculator. Okay, so we have 18 squared is 324. 24 and then 4 times 45 minus 180 and then over 2. Okay, so 324 minus 180 is 144. So we have -18 plus or minus square root of 144 over 2 is equal to -18 plus or minus 12 over 2. So then we have canceling out, that's 2. And then denominator we have -9 plus or minus 6. So we have either x is equal to -3 or x is equal to -15. Right?
Would it be the other way, like this, because there wouldn't be, it would be +3 and 15?
No, so this is already solved for after you have 0. Like if you were to separate, it would be an x plus 15, x plus 3.
Oh,
When you
yes.
solve for what x is, then it'd be x is -3 and -15.
Mhm.
Oh, okay.
Yeah, it separates into x minus plus 3, x plus 15.
Oh, okay, that makes sense.
Yeah, then you subtract them over the other side. Yes. So, okay. So our solutions are x is equal to -2, -3, -15, and then -2 plus or minus 2 over the square root of 7 over 6. Good?
Just remember to separate the plus and minus on the
Yeah.
test.
Okay. So let's see. Yep, we have. Wait, hold on.
Looks like we didn't block that.
Oh my gosh.
Did they forget this part?
I don't know. Because I feel like we did it right. Yeah.
Whoa. All right, so the reason why the other two don't work, if you plug them into the first part that has a square root, you'll get a negative number.
Oh.
And so when it says determine all the real number solutions, it wouldn't work. But if it just said determine all like solutions or determine all complex number solutions, it would.
Yes. Yep, that makes sense. Okay. Okay, any questions on this? Okay. Okay. Let's see. So now we do a little bit of substitution to make our solving easier. So we're presented with this. I will quickly bring over the 20 to the other side. -20 is equal to 0. Okay. Now we're going to let u equal x squared. So if we let u equals x squared, this equation turns into u squared squared, or x squared is x4, so u squared, minus 8u minus 20. Okay, now here we can do the quadratic equation or factor or whatever, okay? So here I see that we have negative, not negative, we have two numbers that equal negative 20, and then two numbers that add up to negative 8. They're gonna be negative 10 and 2. Okay, so then we have u minus 10 multiplied by u plus 2. Okay. Okay, so then we have putting x squared back in, we have x squared minus 10, and then x squared plus 2. So one of these has to equal 0, at least one. So we have x squared minus 10 is equal to 0, gives us x squared is equal to 10. So then we have x is equal to positive or negative 10, square root of 10. Oh my goodness. And then for this one, we have x squared plus 2 is equal to 0. So we have x squared is equal to negative 2. So we have x is equal to square root of negative 2 plus or minus square root of negative 2. So you have x is equal, bringing the negative out, plus or minus I square root of 2. Any questions on this? Yes.
Sorry, you have a question, but because I haven't done substitution before. Is it pretty much just using the situation where it's x to the 4th or something like that? Like,
I would say for now, yeah. We might do some more substitution later on, but yes, it's just to make it so we can technically look at this and just use the quadratic equation right off the bat, but to kind of make you see why we use a substitution. Yeah. Yes.
Okay, wait, so why did we put that I in the next, like, solution?
In this one?
Yeah.
Right here, we said that we had x squared is equal to negative 2.
Okay.
So if we take the square root of both sides, we have x is equal to plus or minus the square root of negative 2. And then that negative 1, we can filter out as I. So we have x is equal to plus or minus I square root of 2.
Oh, thank you.
Okay, any other questions? Okay. Okay. All yours.
All right. Functions. So, as we've learned in class, a function is that if you put in any x value that's in the domain, you'll get one y value out. That's what a function is. And for this, it says specifically any real number, because if we put in a complex number into the equation, it's not going to be a function. So just remember it's any real number. When finding the domain, you should look for piecewise functions. So that's where you have the multiple parts, and then they're restricted to certain x values. Fractions with x in the denominator. So always remember you can't divide by 0, and you can't take the square root of a negative number, because then it becomes a complex number. So we'll go into a problem. What is the domain of function f defined by the set? And as I said before, domains are the x values. So if you just have a list of points here like this, you just take the x value out of each of the points. So you have your little brackets, and then you list them all. So -1 for the first point, 1, -2, 2, -5, 5, and -7. And because they're points, we wouldn't do something like -5 or -7 all the way to 5. because there are fractions in between each of those points. And so the domain is only each of these individual values. Are there any questions on this? Yeah. There we go, right at the bottom. Interval notation. So you have your parentheses, which means that that point or that x value is not included in the domain, and your brackets mean it is included. So for this, this number line down here, write your intervals starting with the lowest number and ending with the greatest number, connecting intervals with U, standing for union. So here you'd have, it goes from negative infinity, and you know that because of the arrow. And then it goes up to -2, and -2, because it's an open circle, is not included, so we do a parentheses. And then you union that with a 3, and 3 is included because it's a closed circle. And that goes up to infinity, and you know that because of the arrow. And with the infinities, because infinity isn't an actual number, that's why you do a parentheses, not a bracket. Any questions on this slide? Okay. Now we will look at a piecewise function. So you have each of the parts. Like was said before, you want to make sure that nothing, you won't take the square root of a negative number, and that you won't divide by 0. In this case, there are no square roots and there are no fractions, so we don't have to worry about either of those. So you take the first one, and this first part goes from -5 to a -2, including -5, not including -2. And then you add in the second part. So you union that with a 4 to a 6. And then you union that with just the 0.2. And the points, you use these brackets. So 2. Any questions on that? All right. And then you see at the bottom, I don't know why they have it brackets here, because I asked the professor that I'm recitating for, and he said specifically that should be like this. And that's how I've seen it on all the CBE practice exams. So I'm assuming it'll be the same way on the test.
The bracket on the first, like before the 5,
Yeah.
like why is it a bracket?
Why is it a bracket? It's a good question. So here, you see how this isn't less than or equal to. So therefore, you know it can equal -5 as well.
Okay.
And then the other ones are just less than or greater than. And so you wouldn't have the bracket.
Okay.
Okay. Now this is a little bit more complicated. This is the one where you have to keep track of dividing by 0 and taking the square root of a negative number. So what you want to do is you'll have this square root of 8x minus 3, square root of 8x minus 3, and you can set that equal to 0 and then solve for it. So we would square both sides, and you get 8x minus 3 equals 0. Move the 3 over, 8x equals 3, x equals 8/3. Okay, now you have to stop and think, what does that 8/3 actually mean? And so what that means is if you were to plug in an 8/3, then you're getting 0 at that point. And so because of that, you can't divide by 0, so you know x cannot equal 8/3. But you also can't take the square root of a negative number. So in this case, you look at whether if it's less than 8/3, is it going to give you negative? Or if it's greater than 8/3, will it give you negative? And so, why is it, I did that wrong. It's not 8/3, it's 3/8. Someone should correct me. 3/8, not 8/3, my bad. So let's say, let's first plug in something that is greater than 8/3 or 3/8. Get mad at me if I say that again. So let's plug in, let's say it's a 4/8. So if you have the square root of an 8 times by 4/8 minus 3, that gives you the square root of 4 minus 3, which is the square root of 1. So that's positive, so that works. Now let's plug in something that's less than 3/8. Square root of an 8 times by 2/8. Yeah, let's erase that. 2/8 minus 3. So that would give us the square root of a 2 minus 3, which equals the square root of -1. And because it's the square root of a negative number, that's not going to be in the domain of the function. So therefore, we know all the values are going to have to be greater than 3/8. If the square root was in the numerator, it could equal 0 because you can have a 0 in the numerator, but because it's in the denominator, it cannot equal 0. So therefore, from this part, you know that x is going to be greater than 3/8. And I'll put that into interval notation in a minute. Then the other part, we have the 1/6x plus 5. So then to see when that equals 0, you have 6x plus 5 equals 0. 6x equals -5. X equals -5/6. Pretty sure I did that one right. And so this was that x cannot equal -5/6 because that'll make it so that the denominator is 0. Now, when you combine these two parts together, so you have the x is greater than 3/8 and the x is not equal to -5/6. -5/6 is not greater than 3/8 to begin with. It's less than 3/8. So we only have to actually worry about that part. So the interval notation would be that it goes from 3/8, because 3/8 is the lowest amount, to infinity, because it can be however big of a number you want to put in there. And so this is your answer. And then you have it at the bottom. Questions on that? No? Okay. Here, let's say, just as a theoretical, what if this were a 6x minus, so let's say this was 6x minus 5. And so therefore, when you solve it, you get an x cannot equal +5/6. In that case, +5/6 is greater than 3/8. So if you were to write that interval notation, you go from a 3/8 to the 5/6, but it can include 5/6, and then you union that with 5/6 to infinity.
Why didn't you have to do -3x minus 2 as well? Like the one that's in the numerator? X in the numerator?
Okay, yeah, so why don't we have to set that equal to 0?
Yeah.
So the reason for that is because we can have the numerator equal to 0. It's just we can't have the denominator equal to 0.
Okay.
Yep. Okay. Problem 10, part 1. So this is evaluating functions at a specific point. So you have evaluate f of 2. That means that x is equal to 2. So you plug in 2 for every x you see. 3, 2 squared minus 4 times by 2 plus 8. 2 squared is 4, so you have 3 times 4 minus 4 times 2 is 8 plus 8. And then that is a 12. -8 plus 8 is 0. So you get 12 as the answer. That's what you see down there. Questions on that? Okay, and then part 2 is if it just gives you x plus h. So you plug in x plus h for every x value. If you take calculus, this will come up, and I think that's why they teach you this, is because it is a pre-calc class. So I don't think you'll deal with it a ton in this class, but it's good to know anyways. So 3x plus h squared minus 4x plus h plus 8. You could distribute, but you don't have to. And as you can see at the bottom, that's the solution. And were there any questions on that? Okay. Then there are other resources if you need extra help. Yes.
Oh, sorry, this is, okay, it's not
Go for
necessarily about the math, but on the test, do you know if we have to distribute on x plus h? Like put the 3 in x and h and 4 in x and h, or if we can just leave it as that?
I think so long as you have those parentheses just like this, then the computer will recognize that they're equivalent either way. And so long as you have the parentheses, you should be fine. Because pretty much what the computer is checking is they have like a certain input, but they'll run like the calculations and stuff to make sure it's equivalent. And so they'll just check to make sure it's the same. Does that make sense? Okay. So other resources, if you want extra help for studying, is you have the AMLAC right here. They're open Monday through Friday and Saturday. I think they close at 2 on Saturday.
It's 10 to 2 on Saturday.
And then Friday, they close at 4. I think that's the same as Monday.
Monday is 5:30.
Okay. And then the other days are 7?
8.
8. Basically, if you go and you search up like USU, AMLC, or Aggie Math Learning Center, then the USU page will pop up for it. Their hours are on there. And you could also schedule Zoom tutoring. They have that available as well. And they also have videos on there for 1050. So those are some other resources. And that is it. Thank you for coming.
Thank you.